So I'm a developer advocate here at Google. Normally I do crazy live demos, but unfortunately you won't see that today. Instead, I want to go through some really cool features that we have at GKE that I think a lot of people, in the documentation gets lost somewhere, and they just don't know it's available. So before I get started, I do want to know that let you know that there's a Dory available. Dory is how we ask questions internally at Google during presentations. And so you can go on your app and do that Dory Q&A thing, and you can ask questions by just typing them in. So GKE, or Google Kubernetes Engine, how many people are familiar with this? Most people, yep. So GKE is basically Google's managed Kubernetes offering. What is a Kubernetes engine? Basically, it's a one-click solution that lets you deploy your master and your nodes, create those, provision those for you, and give you access to them, right? And so you can access that master. It's kind of hidden away from you. You don't have to worry about it. We take care of upgrading it and patching it and doing all that good stuff. And at Google, of course, we've been doing containers for a really long time. Most of you have probably seen a slide similar to this. We launched C groups and open sourced it way back in 2006. Kubernetes was open sourced in 2014, and then GKE went generally available 1.0 in 2015. But so what? Everyone is doing Kubernetes now, right? All the cloud providers have Kubernetes. Random mom and pop down the street has Kubernetes. As long as you pass the conformance tests, you have a Kubernetes, right? So what? Why is Google different? I really think that there's fundamental things that need to be done around Kubernetes to make it useful, right? Just having Kubernetes by itself is great, but it can be a lot harder to use than it needs to be. And so there's three major areas where I think you need support around and a platform that's built around Kubernetes to really make a big difference, right? So one is infrastructure. And then we have networking and security, and tooling and automation. So let's talk about infrastructure to start. So these are things we take for granted every day. So cluster creation. Yeah, it's literally just one command, and you get your master and your nodes, right? Gcloud container clusters create, give it a name, and boom, you're off to the races. Other people might make this a little harder. If you're doing it yourself, you know how hard it is sometimes to set up Kubernetes manually. With GKE, one command, and we're good to go. Pretty straightforward stuff. Everyone here should know this. But just, something to remember about we take for granted every day. Speaking of nodes that are automatically created, they're actually automatically updated and repaired. So a lot of providers might update their master version automatically, but then leave node management to you. We kind of believe that the whole thing needs to work together, and so we actually automatically can update and repair your node. So if you go from 1.112 to 13, we can actually, as your master version gets updated, we can update your node version for you automatically. And if something goes wrong with the node, let's say the Docker daemon dies, the kubelet, something goes wrong with it, we can do that. We can automatically detect that with the health check, delete that node, and spin up a new one automatically to take its place. Again, you don't have to do anything. You don't have to worry about the actual infrastructure anymore. So another really cool feature of GCE is node customization. So you can make something called custom VMs with a custom amount of CPU, memory, throw on local SSDs, GPUs, things like that, and you get all that same capabilities in GKE. What this means is you're not limited to certain types of machines that can run on GKE. Any GCE VM can also run on GKE. And this gives you a lot more flexibility. If you need a beefy node to do some sort of workload and you need a really small node to do something else, you can have that mix and match of capabilities. If you need GPUs, like a P100 or a V100 or whatever, easy to add on to your GKE cluster. And speaking of picking the right size, GCE actually has a machine learning algorithm built in to do something called cluster node right-sizing recommendations. So here we can actually look at your utilization of your VMs and say, hey, you're overutilizing your VM. You should probably pump up the RAM a little bit so you can get some more smoother performance. Or this machine is way too big, you're wasting money, downsize it, save a bunch of money on your bill. And again, because it's built on GCE, all these features pipe directly into GKE. Now, one of my favorite things is preemptable nodes. And I don't think people use these nearly enough to take advantage of them. So I actually did a 3-month data collection experiment where I ran an app that was constantly pinged, and I wrote a bunch of data, and I did a bunch of data analysis. And I found out that you can basically run 3 times your capacity for the same cost and get almost no detectable baseline difference, right? So if you had 1 node for $10 and you had 3 nodes now for $10, yes, those preemptable nodes can die. They get preempted every 24 hours. They might get shut down. But it happens at such a irregular basis, and Kubernetes is so resilient on spinning up the containers to take its place, that if you're running stateless workloads and you're not using preemptible VMs, you are definitely leaving money on the table. I have a whole blog post about this where I go into detail. Ooh, animations. So of course, I talked about how you can kind of mix and match those different types of VMs together. And so the way we do that in GKE is something called node pools. And so again, something that I don't think people take advantage of. Most people make a Kubernetes cluster, and they have one type of node. You can actually take different types of nodes, give them different labels and tags, and then run different workloads on those. So your database can go on a more CPU-heavy, memory-heavy node. Your stateless web app can go on the smaller nodes that are cheaper. Your machine learning workloads can go on your GPU nodes. And you can have them all in the same cluster, which makes networking and all that kind of stuff a lot easier to set up. And another big feature that we rolled out about last year is regional clusters. So by default, clusters are created in a single zone, right? The problem with that is there's twofold. One, if that zone goes down, well, then you're out of luck. And 2, during a master upgrade, the cluster might still work, but the API server goes down, right? So you can't give it updates and things like that. With a regional cluster, we actually spread those nodes over 3 different zones in the same region. And so this gives you, 1, higher availability, right? If a zone goes down, you're still good. You still have those 2 other zones that are up and running. And 2, higher master availability, because you have highly available masters. Because we have 3 different masters, 1 in each zone. When we do an upgrade, we actually do it 1 at a time, so you never lose access to your Kubernetes API server. Really cool stuff. And if you're using regional clusters, you can use regional persistent disks. Now, these are really, really cool. So basically, it creates 2 disks, and one is a clone of the other. And any write that's sent to the first disk is just forked at our network level to both disks at the same time. So any writes that go in are actually written to both disks simultaneously with no performance downgrade, right? And so what happens if zone A goes down, zone B becomes hot and starts serving data, and there's no real disruption to the end application. And this is actually how Cloud SQL for Postgres runs under the covers. It uses these regional persistent disks to provide high availability. And because GKE has native built-in connections to all of this stuff, you can use it as well in GKE. Now, another important thing is autoscaling. And so everyone can do autoscaling based on CPU, pretty trivial. But with Stackdriver and with GKE, you can autoscale on custom metrics. So anything your app needs, like number of incoming requests or number of open file handlers, whatever you need to scale your app, you can send that to Stackdriver and scale your GKE nodes based on those metrics. And speaking of autoscaling, GKE provides something called vertical pod autoscaling. Now, how many people are familiar with horizontal pod autoscaling? Most people. So horizontal pod autoscaling is pretty straightforward. You run out of CPU, you spin up another pod, you spin up another pod, it spins out horizontally. But vertical pod autoscaling can actually set your memory requests per container and actually make them go bigger or smaller depending on the workload. So we actually, again, use machine learning to figure out how much memory your container needs. So if it needs more, we'll actually redeploy those pods with more requests. And if they need less, we'll spin them down with less. So we're actually spinning the pod requests up and down for you automatically. So we can do both vertical pod autoscaling, horizontal pod autoscaling, as well as cluster autoscaling. So it's like multiple dimensions of autoscaling all at once, and we optimize that all for you, which is really cool. Ooh, look at that. And of course, today we announced Anthos and GKE on-prem, so we can do all this really cool GKE stuff, or most of it, not only on our cloud, but on-prem and in other providers as well. So that's really cool, and there's other talks that can go more into detail on that. So I talked about the infrastructure, and now I want to really get into the bread and butter of where I think GCP shines, especially in terms of GKE. So when you go from a monolith or a VM-based architecture, a lot of the networking assumptions you make change dramatically when you move to containers and microservices, right? The networking gets way more complex, and if you're not built from the ground up to support that kind of stuff, things can fall apart, right? The old paradigms kind of fall apart. So let's talk about networking first. So normally, you have your nodes, and you have pods on those nodes. And so these nodes are VMs, and they have IP addresses on the VPC, right? But those pods, the IP addresses that they have are virtual IPs that are only routable within the cluster. So the problem here is that when you want to send a request out, those IP addresses get masked with NAT, and so the node IP address goes out, not the actual pod. So you don't really know which pod on that node is making that request. And the same thing coming in, it's really hard to route traffic to a pod on the node because you have to go through the node first. But with IP aliasing or VPC Native Pod IPs, those pods actually get real GCP IP addresses that are natively routable on the VPC. So what does this let you do? It lets you do really cool things like container native load balancing. So in the old world, you spin up a load balancer. That load balancer has no idea what's running inside of those VMs, right? It just knows send traffic to that pod, VM on this port, and then IP tables inside of that node has to do another routing to the actual pod, right? And that pod might not even be running on the same VM. We call this a double hop problem. So it might go to one virtual machine and then get routed to another virtual machine and then go to the pod, right? A lot of hops, a lot of latency that's added to your infrastructure. With container native load balancing, our load balancers actually know the physical IP addresses, well, not physical, everything's virtual these days, but the actual IP address of the pod itself, and can route traffic directly into that pod without going through IP tables, without going through natting, without any of that stuff. So you get a lot less latency, and more importantly, you get more transparency. You don't have to go through your logs. If you go through your VPC flow logs and like, OK, well, I went from this VM to that VM and then to that container. Instead, it's just from that load balancer, that container, straight line, right? Much easier to reason with and debug and analyze. And speaking of load balancing, we have internal load balancing as well. And so this, again, it's straight built into Kubernetes, so you can provision an internal load balancer the same way as an external load balancer. And so this lets you expose your Kubernetes services to non-Kubernetes services inside GKE, inside Google Cloud, right? So if you have a service running on VMs, a traditional kind of thing that you haven't migrated to GKE yet, you can just expose your GKE service, and it gives you an IP address that's routable inside of the VPC. And the really nice thing is because this is done with an SDN, there's no overhead, and everything is just done. There's no box sitting there, right? We just know where to send the traffic. And the other way around, Cloud NAT. So if you have a third-party service that requires a whitelist of IPs, well, it's kind of hard to do with GKE. Those nodes come and go. The IP addresses change. You might spin up your cluster to make it bigger or smaller. So how do you give them a whitelist of IPs? Well, with Cloud NAT, you can actually create an IP address, and all the traffic gets routed through that IP address. So it looks like all the traffic's coming from a single IP address, but it's scalable because, again, we're doing SDN magic under the covers to make it look like the traffic is coming from this IP. So you just give that IP to your third-party person, they whitelist it, and you're good to go. You don't have to worry about managing a list of IPs and things like that. And then we have multi-cluster ingress. So this is really cool. You have a bunch of clusters around the world. You can spin up a single load balancer with a single IP address, and it can route traffic to all of your clusters automatically, right? So we actually find the closest cluster to the user using Anycast, and we can route their traffic to that cluster without you having to do DNS or anything complicated. And I actually have a talk a few years ago at Next where I spun up a multi-cluster ingress using Kube Federation, which is quite a while ago. So if you want to check that out, check it out. And then we have deep integration with other networking products like CDN, IAP, and Cloud Armor. So Cloud CDN, as the name implies, is our CDN, really powerful stuff. IAP, the Identity Aware Proxy, lets you throw this little proxy in front of our load balancer that we call it Beyond Corp. You can read the paper. Basically, like, you don't have to build security. If your application requires something like a VPN to connect to it, right? If you're using VPN for security, this is an alternative where you don't have to use a VPN. Instead, you can use OAuth to authenticate you as an end user and then log into that service. So for your application, it still looks like it's in the VPN, but this proxy kind of lets you do that without VPNs, which is really nice. And then Cloud Armor, which is our anti-DDoS protection. And these are not just built like add-ons. These are, you can actually configure all these things with Kubernetes native objects, which is really cool. All right, so security. Security is really important, especially in Kubernetes land. How many people saw the Tesla crypto mining thing? Yeah, so their cluster got hacked, and people started running crypto stuff on it. And so what I'm going to talk about now is kind of layers of security that we add to make it more harder for an attacker to get into your systems, right? So the first thing is private clusters and master authorized networks. Private clusters, it's literally what the name implies. The cluster doesn't have public IPs, therefore it's only internal, right? And again, master authorized networks, only certain people can log into the master, not some random person on the internet cannot like SSH into your master, right? So again, just another layer of protection. So if they break into your network, then yeah, they still could log into your master. So how do we get around that? So we have something called network policy. Network policy in GKE is we automatically install something called Calico into your cluster to make sure that when you set these network policies, they're enforced. And so these are really powerful stuff. You can say, this namespace can talk to this namespace, but not the other way around. Or these pods can talk to these pods, but they can't talk to any other pods. And so my coworker Amit has a really good blog post and a GitHub repo that goes through all these these network policies and how they work. Highly recommend checking out. That's where I stole this picture from. But it gives you, again, another layer of control, right? So if someone is able to break into the app web, they can talk to any containers, but the containers can't talk back, right? So you get a little bit more control over what's going on. Kubernetes secrets. So for the longest time, Kubernetes secrets were not encrypted. In more recent versions of Kubernetes, they are encrypted, and with GKE, you can actually encrypt them with Cloud KMS, and so you can manage those encryption keys and rotate them and do everything that you can with Cloud KMS, but now for your Kubernetes native secrets. Again, just making it easier to use, right? And then binary authorization. This is a really cool new feature. Basically, let's say someone does break into your Kubernetes cluster, and now they want to run cryptomine.latest or something like that. Well, they can't because it's not authorized. So we can actually enforce signed containers. So only containers that are signed by you can actually even run on your cluster, right? So again, rogue developer who wants to run something can't do it. It has to be signed. So this is really powerful, again, locking down another layer of security that we give you in GKE. Now, how many people know about this? Container registry vulnerability scanning. A few people. Yeah, so this is really cool. If you're using Alpine or Ubuntu, it actually automatically scans your containers for known CVEs, and it'll surface those for you. So you can see I uploaded some really old containers, and they have tons of issues, as expected. And you can go through and see what's important to you, what you should update, and things like that. Usually, if you're building containers fairly regularly, they should be fairly up to date. But this is a good way to see, oh, I have an old container with a bunch of vulnerabilities. Let me update it. Or, hey, this new vulnerability came out. Let me make sure that I'm not being affected, right? So really cool stuff. And again, built straight into GCR. So the last section, monitoring and tools. These are things, again, I think people forget about, or to just kind of, it's there, I don't remember. But when you don't have it, you're like, I really wish I did. So one is Stackdriver Kubernetes monitoring. There are quite a few tools nowadays to monitor Kubernetes. Stackdriver has been updated to monitor not just the VMs that are running your cluster, but actually your pods and your services that are internally, right? So here we can see we can't see anything because that's like a super blurry picture. But if you could see that picture, you would actually see the nodes, the pods in those nodes, how much memory they have, they're healthy, all the custom metrics that you sent, all in one pane of glass, which is really nice. CI/CD is necessary. Cloud Build is one way of doing that. And I think Cloud Build is a really easy, lightweight CI/CD tool that you can use, especially for if you don't have anything too complicated. You just put your steps in, it runs those commands, and it can build your container for you. And you can do more complicated stuff, like actually deploy to Kubernetes, run health checks, do all this kind of stuff. It's a very simplistic product, but it really has a lot of power. And because it's completely serverless, you don't have to worry about provisioning a CI/CD build pipeline or anything like that. You literally just run a job, and it just runs it for you. And you get tons of free build minutes per day, which is really cool. Now, this one is something that most people, again, don't really think is a differentiator. But the GKE dashboard is really powerful. You can see your workloads, you can see your services, you can drill really deep into these things with a really nice GUI. You can edit them right from there. You can create new deployments. You can look at the status. You can do all this kind of stuff, again, without writing a single line of code or going into a single command line, right? Right from that Pantheon dashboard, you can see everything that you need, which is really nice. The service broker. This one is really useful if you want your Kubernetes operators to be able to provision other GCP services, or for that matter, open source services or even other cloud services directly from GKE objects, right? So you can say, hey, spin up a Cloud Firestore database, and it'll just spin that up for you and give you those credentials back as native GKE secrets. Really, really powerful. And it gives you a better integration into the rest of both Google Cloud and the open source ecosystem. And finally, I'm going to talk about namespace and label resource usage. So how many people here have a GKE cluster shared between teams? A few people. So a really cool thing is you can actually export usage based on namespaces and based on labels. So let's say that you have namespace X that's used by team 1. You can actually see how much of the cluster that they use versus namespace Z. And the same for your apps. So if you have two apps labeled app A, and they're in different namespaces, you can, again, get that export of the resource usage for those apps outside of the place. So really cool stuff, especially if you have multiple teams using the same cluster and you want to break that down for analytics purposes. So we have two add-ons that I want to talk about because I think they're really powerful. So one is the GKE Istio Add-on. You click one button when you're creating your cluster, and you get Istio installed into your cluster for you automatically. Really cool stuff. If you don't know what Istio is, I'm sure there's some talks around here that you could probably wander into. But long story short, it's called a service mesh, and it really adds a lot of value to if you're doing microservices architecture on GKE. It adds a lot of value for you automatically without you having to do too much work. If you don't know what Istio is, go look it up. It's pretty cool. And then we have Cloud Run on GKE as well. And so this is built on top of Istio and Knative to be able to run serverless workloads on top of GKE. So it's the same Cloud Run APIs that you can run serverlessly on GCP. You can actually run it inside of your Kubernetes cluster as well. So you get the same developer experience end to end, no matter if you're running on our serverless platform or on our Kubernetes platform. But don't take my word for it. With me, I have Brad from Symphony Communications. He's the VP of Architecture here, and I want to give him the floor to kind of talk about his GKE experience, and here you go. Yeah.
Thanks, Sandeep. And so, as many of you, we kind of embarked on the Kubernetes path a while ago, looking at the ability to containerize an application. The application, of course, has been around for longer than what we actually wanted to do with containerization. We were doing a lot of the heavy lifting that Sandeep described. We were running virtual machines, we were maintaining those virtual machines, operating systems up, and trying to keep a secure platform. What Symphony actually is it's a secure team collaboration platform, but it is really focused on financial service customers as our primary business segment. And if you've ever worked with those customers, you know that they are extremely sensitive to security. So security was always kind of at the core of everything we do. And we've worked for a couple years now with the GKE team, specifically around kind of crafting the security messages that you heard from Sandeep, working with the product managers, telling them what was important for us and our customer base, so that it becomes more accessible across the entire industry, not just something that you can actually focus on from an internet-based application, but actually something that individual banks and large financial services institutions would start to trust as well. And that's really, again, what Symphony is and where we see a lot of value and a lot of continued innovation in trying to drive that security, things like the private GKE clusters, the ability to actually know that, banks still think about how we're going to actually get into our networks, make sure that everything is signed. Signed images are going to be very important from our perspective as well, so that we can actually have high confidence that the cluster is only running what we want it to run, and the individual teams within both our organization and our customers' organizations have good visibility and good auditability around what that's running and where those individual pieces are able to talk to each other.
Cool. So Brad, I have some canned questions for you.
Sure.
And then we'll open up the floor to questions from the audience. And again, remember that Dory is available if you want to just type it in, if you don't want to come up to the mic. So when you chose GKE as your platform, kind of what was one of the biggest challenges moving from, again, you said like a VM-based architecture to the container-based architecture?
Sure. So we actually are dual hosted. We've been hosted in AWS and GCP for a long time. We had been on both in the VM world, but we treated our VMs very much like you would consider an internal data center. And in fact, part of our architecture does include our customers' data centers as well. That's one of the reasons that we can actually have the security model that we have. So we've always been looking at ways to optimize the efficiencies around how do we administer AWS, GCP, and our customers' data centers. And that's really where Kubernetes and containerization shines. It gives us the ability to package our application in ways that we can deliver to our customers on-premise. They do it in GKE on-prem in some cases, but they do it in Cloud Foundry or other things that are container-based orchestration systems. We build our containers for our cloud system to really kind of evolve the platform there. It was some heavy lifting. I mean, many of you have probably been through it. The assumptions around VM, some of the things Sandeep already mentioned, they have to be rethought, and the architecture has to be evolved.
Yeah, so speaking of re-architecting, so has Kubernetes and GKE kind of forced you to re-architect or reconsider some design decisions that you've made in the past?
It is, but I mean, part of it is you mentioned monolith earlier, and our original application, like most as early startups get started, tends to be a little bit monolithic, and so that's really what we're looking at right now: is how do we break the monolith in such a way to gain resiliency, gain scale at the right layers that make sense, allow teams to operate, because we have 150 to 300 engineers, depending on how you count the external help that we have, that are driving in parallel. And as you guys know, trying to get everybody aligned and everybody heading in the same direction is really difficult, and microservices can make a big difference there. We're still breaking apart the monolith to some extent, but that's the evolution path that many of you are on, and that's we're on as well.
Yeah, so what we say the biggest challenge in breaking or decomposing, let's say that, it's a nice word, in decomposing your monolith, right? So it's a really long journey, as you mentioned. What's kind of been the hardest part, and then how has GKE kind of helped you do that?
Sure.
Yeah.
So I mean, the nice thing about GKE is the ease of access that Sandeep already mentioned. Spin up a cluster with one command. We've had kind of our engineers that we've been training. Google actually offers a bunch of training support too. Our TAMs have come in and brought in individuals to show us and our teams how to use Kubernetes the right way, best practices way, so we can actually evolve the thinking. The hardest part from in my opinion, of how they do this is rarely the technical part. The technical part, a couple of people can sit around a whiteboard and break up the thing and decide the right way to break it up, the right contracts to make sure the services talk to each other. But if the engineering team, if the talent that you have don't understand the tools well enough, or don't understand the methodologies you're trying to achieve, that's where you can get a lot of advantage just by the accessibility of GKE. There's no reason that we should have to spin our own Kubernetes cluster to learn Kubernetes with GKE.
Okay, and so final question. I guess it's two questions in one. What's the most exciting thing about GKE for you, or the future of GKE? What's the most exciting thing that you see on the roadmap that you're excited about? Maybe that's public, but and then more personally, what do you guys are building inside Symfony that you really want to talk about and are super excited about?
Well, I can't talk too much about the latter one. Again,
I tried.
We are doing a bunch of things around workflow automation. You see these things happening. You see autonomous agents happening in the industry. We are a tool very similar to Slack or Microsoft Teams, although we're focused much more on the security and the compliance aspects. But all those same things that you see happening on those tools, even things like chat ops that you guys are probably already doing in your teams, are just as relevant for our customers in our financial services industry. And so we really see a lot of value about bringing containerization to those tools that our customers are building as well. And one of the pieces, you mentioned GKE on-prem. One of the pieces that is still difficult for us and our customers is that on-prem piece. We'll never get rid of it. It's part of our architecture. It's a key part of our architecture. We also won't be administering our on-prem clusters because they're our customers' data centers. But they may opt to use more and more of GKE on-prem to really kind of aid themselves in making that an easier tool for them to use. Mm-hmm. But our customers are also, like I said, very security conscious. And so we have to understand that some of the kind of cloud-managed on-prem infrastructure for them is something that they have to kind of work through and understand the security implications of. They're really uncomfortable with things reaching from the cloud back in. Mm-hmm. They have very constricted firewalls, and
border security in a lot of their data centers. So it's something to consider. And as GKE evolves, certainly there's kind of an air gap notion of potentially how we might view and administer a cluster without actually having direct access to it.
Cool.